Welcome to Ivy Lab's Summer Intern Project 2023. Our project focuses on developing a 2 degree of freedom gimbal. Our primary objective is to stabilize camera payloads and preserve their orientation, guaranteeing the acquisition of smooth footage even in dynamic conditions. This technology will enhance the quality of video recording, allowing for more professional and visually appealing content creation. The gimbal uses a PID controller to smoothly stabilize the orientation of the camera. These are the components used in our project, which include a microcontroller, an inertial measurement unit, and servo motors. We worked together on this project in 2 distinct phases, first focusing on software development and then on hardware implementation. Firstly, we learned the basics of classical control theory along with the parameters and tuning methods for PID controllers. Then, we moved on to simulate our hardware using Walkway Online Simulator. Here, we collect data from the IMU and map changes in angles onto 2 servo motors. Moving on to hardware, by using Arduino and utilizing the data from the IMU, we employed a polar plot visualization to map the captured angles. This was achieved by setting up a serial communication between Arduino and Python to import data from serial plotter. We integrated servo motors controlled by a PD feedback loop using IMU data for optimal stabilization. The integral gain term is kept at 0 due to drift error accumulating at default. Drift can be reduced by calibrating the IMU on a software level. Once the IMU readings were mapped, we created a prototype model using steel links to verify the working of our gimbal system. Then, we designed a 3D model of our 2 degree of freedom gimbal using AutoCAD Fusion 360. The parts were created using a 3D printer and then assembled. The IMU and our phone were attached to a gimbal to stabilize and record footage respectively. And after some more testing, here are the results. Some further improvements that can be made in our gimbal system are 1. Adding a 3rd degree of freedom for complete 3D stabilization. Integrating OpenCV into our gimbal opens the door to multitude of functionalities, significantly enhancing its capabilities.
These are the team members who contributed towards this project. Special thanks to our mentors Kishore and Pratyush for their support. Finally, a heartfelt gratitude to Sheetal ma'am and Ivy Labs for this opportunity.